All right, everybody. So now we're looking at learning target 8. I can recognize and extend patterns. And I am starting with this problem on part 2 because I think it is the most time-consuming and difficult problem. It sure looked that way from test number 1. So let's go through it together. All right, here we have figure 1, figure 2, and figure 3. And the first part asks how many little triangles are in figure 1, figure 2, figure 3. Well, that's easy, right? All we do is count the number of triangles. But then there's a second part here, part B. Set up a table showing the number of little triangles in each figure. Look for a pattern and extend the pattern to figure 5. Okay, so I'm going to tie these two questions together because that's going to save me a little bit of time. So here I am creating my table. And when I create my table, I'm going to want an X and a Y value. And so what do I want to put for my X? Well, my input is going to be my figure number. And then my Y, or my output, is going to be the number of triangles. In other words, as my figure number changes, what does it do to my number of triangles? All right, so my Y is going to be red here. And let's go ahead and take a look at figure 1 right here. I have 1, 2, 3, 4, 5, 6 tiles. And you'll notice when I look at figure 2, I can actually outline those first 6 tiles that I saw in figure 1. So there's my 6 again. And then what am I adding onto that 6? Well, it's going to be these 4 triangles here. So 6 plus 4, there I have a total of 10. All right, so let's go ahead and freeze for a moment. My first figure has a total number of 6 triangles, as shown here. My second figure has a total number of 10 triangles, as shown there. And then my third figure has a total number of, well, let's go ahead and see what we got here. We got our initial 6. We add our 4. So there's the plus 4. And then we add another 4. All right, so 6 plus 4 plus 4, that is going to give us 14. So it looks like we're adding 4 each time. And we could continue that. We'd say 18, 22 for our next 2 figures, 4 and 5. And now we are trying to figure out a pattern. All right, so that way if it asked for like figure 100, right? Sometimes we get those ridiculous questions. We don't have to draw out all of the figures. That would take forever if we had to draw them all out and count. And I don't want to count by 4s each time, so I'm going to really try to figure out a good pattern here. All right, so first off, I'm looking at what is my constant. In other words, what is always going to stay the same in each of the parts of my table. All right, well, here I'm seeing there is a 6 in every single one of these figures. So my constant is going to be 6. I'm always starting with 6. And so I'm going to do plus 6. And then I need to figure out what I want to put before that. Okay, so if I'm starting with, say, I'm going to do this in green here. If I'm starting with 1, figure 1 for my x, so I'm going to do 1 in for what would be my x in my expression. What do I have to do with this 1 to get it so when you add 6 at the end, it equals 6? All right, so I'm going to do equals 6 because I know that's what I need to get it to equal. That's my y. Well, let's see. I could subtract it by 1, right? Because 1 minus 1 is going to give me 0. And if I add 6 to that, that'll give me 6. So 1 minus 1, that'll give me 0. So 1 minus 1 gives me 0. And then if I add my 6 that I still have there, it's going to give me 6. Okay, so that looks like a pretty solid rule. Let's see if it works for the next one. Okay, if I do 2 minus 1 and add 6 to it, 2 minus 1, add 6 to it. Oof, that does not give me 6, right? That gives me 7. So what could I do here? Well, we go up by 4 each time, don't we? Right? We're going up by 4. one time more than the last. So maybe if I go up by 4 each time, I could multiply 4 by whatever my x minus my 1 is, and then add 6. Let's go ahead and try that. So here I am going to do 4 multiplied by 2 minus 1. So that'd be 4 multiplied by 1 plus 6. Ooh, I think this one might work. 4 times 1 is 4 plus 6. Hey, that equals 10. So if we plug in our input of 2, we get an output of 10 based on this formula. Okay, I think I got it. So let's go ahead and check this a few more times. And if you're a little confused by what I'm saying, try to stick with me here because I'm going to go ahead and erase what I have. All right, so I think I have found the rule of 4 multiplied by whatever my x is minus 1 plus 6. That's going to give me my desired y value, or just my total here. So here, if we plug in a number for x, and we'll do this in purple because I like purple. Let's go ahead and plug in, say, 3. So I'm going to substitute in 3 for x. And now my equation looks like 4 multiplied by whatever 3 minus 1 is, plus 6. That is going to give me my y, which in this case for 3 would be 14. So is this true? Well, let's go ahead and solve, and I'm going to do this in black. 3 minus 1 is going to give me 2. So now I have 4 multiplied by 2 plus 6 equals 14. 4 times 2 is 8. 8 plus 6 does in fact equal 14. All right, so this works. And so now, if it's wondering what we'd have for figure 5, well, we showed that here in our table, but we actually can show it by plugging in 5 for x. So let's go ahead, plug in 5 for x. So I'm going to do 4 multiplied by 5, right? Our input is 5, minus 1 plus 6. Our constant should give us 22. Let's see. 4 multiplied by 5 minus 1 is 4, plus 6. So 4 times 4 is 16, plus 6. That is going to give us 22. Hey, just like we have right here. We put in 5 and we'll get 22. So my rule, or the pattern that I have found, is that if we do our figure number minus 1, multiply that by 4, and then add 6, our constant, that's going to give us our y value, or our total number of triangles in each of the figures. All right, this was a little complicated, but hopefully you were able to see what I did. And now we can figure out, if we wanted to, what the 1000th figure would look like. So that's pretty cool. All right, moving on to finding the perimeter and area of rectangles. All right, so here with the perimeter, we're talking about the outside. So think about like a fence that would be surrounding a yard. We only care about the length of the fence. We do not care what's on the inside of that fence, okay? So here we're looking at the length and width of 10. So let's say we gave a width, or a length of 6, a width of 10. Would this give us 32? Well, we do 6 times 2 and 10 times 2, and that would be 12 plus 20. That gives us 32. So it can't be this first option. And this next time around, we are going to do part B, which is 6 and 8. So 6 and 8. Well, we do 16 plus 12. That's not going to give us 36. Which one of these is going to give us 36? Ooh, what about this one here? So if I do 2 times 8 plus 2 times 10, 16 plus 20, boom. We have found it. 36 as our perimeter, the distance around the rectangle. And we are golden. We don't even need to check D and E, although might not be a bad idea on a test to do that. All right, looking at part B. What is the area and perimeter of a rectangle with a width of 9 meters and a length that is twice that amount? Okay, so here we can just use algebra again. We could say 9 plus 9 times 2. All right, so here we're going to do 9 plus 18. It's going to give us 27. So we can say the area, I'm sorry, we can't say anything here. We have just figured out the different sides. So I'm going to go ahead and draw my rectangle. And we have 9, and there we have 18. So we have 18 over here and 9. And now we're going to figure out the perimeter. Well, if we add all of these together, 9 plus 18 plus 9 plus 18 plus 9, that's going to give us 318, which is going to be 36 plus 18, 54. And I'm going to show my work for that. So it's going to be 9 times 2 plus 18 times 2. And now we're looking at the area, right? So perimeter is donezo. Now we're looking at the area. And that is going to be 9 times 18. Well, 9 times 10 is going to give me 90. 9 times 8 is going to give me 72. So if I add those together, I'm going to end up with 162. And since this is referring to area, that is going to be meters squared. So I can do M with my little 2 here. And that is going to be my area. And that reminds me, I need to fill in my label for the perimeter as well, which we did in red. So that's going to be just meters, 54 meters. And we don't care about what's on the inside, so we're just going to stick with meters and not square it. It's the length around. All right, now we're looking at learning target 11. I can determine measures of central tendency. Okay, so the first thing I am going to do just to help me out here is put these numbers in order from least to greatest. So it looks like 3 is my smallest number and 21 is my greatest number. So let's go ahead and start with that. Here we have 3. Cross that off. 7. 9. 12 looks like my next smallest. I see a few 12s, don't I? 3 of them. And then there's 14 and 2 15s. Then there's a 16. And there's 19, or 18, excuse me. Can't forget about 18. 19, 20, and finally 21. All right, so we have them from least to greatest. That'll help us out big time. So first, we're going to calculate the mean for this data. So that's going to be my sum, or all of them added together, divided by the number of values that we see here. Now, we see a lot of values. Let's count out how many exactly we see. 6, 10, 11, 12, 13, 14. So it's going to be whatever all those numbers add up to be and divide it by 14. That is going to give us our mean. All right, now we're looking at calculating the median. So the median is going to be the number that's in the middle. So we'll do light blue for the median. And I'm going to find the median by starting off at the largest number, crossing that off, then the smallest number, then the largest number, then the smallest number, because this is going to bring me to my middle value. Okay, now notice I have made 1, 2, 3, 4, 5, 6 slashes on numbers over here for the large side of my data, and then I've made 6 slashes over here for the small side of my data. So it would not be proper for me to cross off 15 and favor my smaller numbers. So here, since I have 2 numbers left, I need to find the middle or the median of these 2 numbers. So what number is in between 14 and 15? What is right in the middle of those two? Well, you might know just by looking at it, it would be 14.5, but you could also do 14 plus 15 to get 29, and then divide that by 2 since we have 2 numbers remaining, basically finding the mean of our 2 numbers left in the median. So we're going to have 14.5, and I've showed my work over here. I want to leave it, all right, even though it's messy, I want to leave it, and then I'm going to find my mode. Now, with mode, I think of the MO, and there's also an MO in the word most. So it's the value that I see most often. And I was making that comment about how many 12s I was seeing. I see 3 of them. I don't see any other number quite as many times. I see 15 twice, but 12 is going to be the number I see the most. Therefore, it's my mode. Now I'm looking at my range. So home on the range, that is going to be the range that my numbers run from. And so here, my numbers run from 3 to 21. And I can't subtract 21 from 3 unless I want a negative number. So how many numbers are in between 3 and 21? I would just simply do 21 minus 3, my largest value, minus my smallest value. And that's going to give me 19, which is basically just saying that there are 19 numbers in between my lowest value, 3, and 21. That's the range of my data. So let's say I can make shots from 3 feet away from the basket and also make shots 21 feet away from the basket. I have a 19-foot range to work with. All right. Learning target 12, I can calculate operations with signed, fractions, and decimals. Okay, so when we're adding fractions with different denominators, the key here, different denominators, I have to get those denominators to be the same. So I'm going to rewrite this with both fractions being over 10 because both 10 and 5 can go into 10. So now my question is, how many times does 10 go into 10? Just once, right? You multiply it by 1. Well, what about my 5? How many times does 5 go into 10? It goes in there twice, so I'm going to multiply it by 2. And now I need to do the same thing to my top numbers. Since I multiplied 5 by 2, I need to multiply my 3 by 2 as well. 3 times 2, that's going to give me 6. And then over here in a beautiful light blue, I'm going to multiply my numerator by 1, just like I did my 10 multiplied by 1. 1 times 1 is going to give me 1 over 10. It's just going to stay the same. And so here, now I'm going to add these two fractions together. And when I add these two fractions, it's not like multiplication where I just add across the bottom, because let's say I had a pizza and I divided it into 10 pieces. A pizza isn't the best thing to use for 10 pieces, so I'm going to use a big bar here and divide it into 10 pieces. And let's say I take a fraction of it, like 1/10, shade in 1/10, and then I shade in 6 more tenths. Well, then I'm just going to continue shading out of my total of 10. All right, my candy bar isn't just going to magically get bigger. And so here I eat 1/10 of it, and then I eat another 6/10 of it. So here we're going to need a total of 7 out of our whole, which is 10 pieces. So 7 over 10. Same thing here with subtracting. I'm going to change this 8 into a 16, which means I would have to turn this 5 into a 10. And so 10 minus 3, that's going to give me 7 on top. And my 16, my whole, that's going to stay the same. So 7 over 16. And now we're moving on to part C. 3/4 minus 5/8. Same deal there. And then same with adding fractions. 1/3 plus 4/9. So I'm going to leave those for you guys. I don't want to be too repetitive here. All right, now we're looking at simplifying expressions by combining like terms. Now remember, like terms, those are numbers with the same variable after it, okay? So here we have x and I have x. So think about it. It's like we have a team of x's, all right? How many players are on the team x? 18 total, right? 16 plus 2, so I have 18x now. And then how many players are just not wearing uniforms at all? They are running around shirtless. Well, that's going to be my constants, my 5 plus my 8. That's just the regular dudes, and that's going to be 13. So plus 13. And can I simplify this anymore? No, I can't, because I can't mix my shirtless guys with my team wearing X's on their back. And so now I'm looking at my next problem here. And here I have negative 4x, 3x, and minus 4x, or negative 4x again, basically. And so if I were to combine all of those, all right, how many total x's do I have? Well, here I have negative 4x plus 3x. So that's bringing me up to negative 1x, but then I subtract 4 more x's. So that's going to bring me to negative 5x. And then what do I have left over? Well, I have my minus 10. So it's going to be negative 5x. Almost forgot my x there. Minus 10. All right. And we'll do one more together, just because these can get confusing, especially when you bring in x, y's, or a squares. But here's what I want you to realize, and this is probably the simplest way I can put it. What is 5 a squared plus 9 a squared? And basically what I just asked you is like, what is 5 apples plus 3 apples, right? Well, 5 apples plus 3 apples is going to be 8 apples. Just like if I were to do 5a squares plus 9a squares, well, that's going to be 14a squared. All right, math is a language. And so here I'm looking for all of my a squares. There's one. There's one. Notice here, this is just an a. It's not an a squared. So I can't add, apples to oranges like I can't add a's to my a squares. They're two different things. And so here I'm going to have 5a squared plus 9a squared. We said that was 14a squared. Oh, but we're subtracting here. Now we're going to be in the negatives. So we're going to do negative 4a squared. This is a good example here. I was very confident with it, but I added instead of subtract. So we're going to go ahead and get rid of that. Just forget I mentioned all that. But hopefully it does kind of help you realize how math is a language. Negative 4a squared plus, and then here we have 3 minus 8, and that's just going to be, regular 3 minus 8, which is negative 5. And then we have plus 2a. That's off on its own little islands. And if we wanted to simplify this even more, we could simply write this in order of our coefficients, meaning we could write it as negative 4a squared plus 2a, and then we could change this plus negative to simply minus 5. And this would be the simplest way we could write this. Can't combine anything more. And now it says explain why x squared and x are not like terms. Well, you could use my apple example, and you could be like, 5x squared is not the same as 5x, right? They're two different things. You could also say, well, if I were to draw my x piece, that would be like one wall, and then x squared would be my x by my x. Like that would be everything on the inside. That'd be my x squared, okay? So why are they not like terms? Well, you could draw this diagram here, like our algebra tiles, or you could say, because x is not x squared, or simply x squared, right? Two different things. One's talking about area, one's talking about like perimeter, the length of a wall, for example. All right, I can compare two complicated expressions. So simplify the expression mats below to determine which is greater. Write a greater than or less than sign in between the mats. Okay, so here I am looking at positive and negative tiles. Now let's just start off by saying these gray ones are my positive tiles, okay? Confused me at first, so I am just going to highlight everything how I see it. That way I don't get confused. And now what I'm going to do is up top here, I'm going to cross off whatever I can. And so I know that positive x and negative x will cancel out. I know that a positive 1 and a negative x will cancel out as well, which just means that I have negative 1 left over. It's this little guy. And then we also have here positive 1 and negative 1 cancel out. And then if I have a positive x in the negative side and a positive x in the positive side, those would also cancel out, right? Because they're on the opposite sides of the mat. And that leaves me with, again, a negative piece. But my negative piece is in the negative side, which means it's actually a value of positive 1. So which one is greater? The one on the right. Wow, it's like I'm in Minecraft writing in block form. All right, now we're looking at part B, which is greater here. Again, I'm going to cancel out the 2 and 2. And then I'm going to cancel out these guys and these guys because they're on opposite sides of the mat and they're the same type of tiles. So we have negative 1 in the negative part of the mat. So that's going to be a positive 1. And now we need to look at over here, cross off positive and negative, cross off positive and positive. They're on different sides of the mat. And so that leaves us with 2 tiles that are in the negative section, but they're both negative, which means they would technically be positive. Oh, getting confusing, Mr. Nelson. So we have 2 here. What is greater, 1 or 2? My 2 is going to be greater than my 1. Okay, so it's going to be, again, the right side of the mat. And we could show again with the symbol over here on this side that 1 is greater than negative 1. Okay, now it says, I can solve for a variable with algebra tiles if I know the expressions are equal. Okay, so negative 2x is equivalent to 16. So what would x have to be for this to be true? Well, I know that the opposite of multiplying negative 2 by x is dividing by negative 2, right? That'll get x by itself. So I do the same thing to the other side. Now I have x equals negative 8. Beautiful. If you plugged it back into the equation, you see negative 2 times negative 8 does, in fact, equal 16. So here we are on the other side, b, and it says negative 9 equals negative 7 plus 3 plus x. So let's see. I can start off by adding 7. So now I have negative 2 equals 3 plus x, and I need to rewrite it every time. Don't want to skip steps here. And now I want to get rid of this positive 3, so I'm going to subtract 3 from both sides. So now I have negative 5 equals x, or I could rewrite it as x equals negative 5. And we can go ahead and plug it back right in for our equation and check our work. So we're at negative 7, and we add 3, so now we're at 4, and then we subtract 5, so now we're at negative 4, now we're at negative 9 because we subtracted 5. That is correct. And so we can move on and do the same thing here. C and D should be pretty explanatory, same kind of deal. This time we do have for D 2 x's, all right? But remember, x, that is going to be the same value, right? Can't have 2 different x's here. So let's go ahead and solve. We are going to add 1 and add 1. So now we have 4 equals x plus 3x. And now we can combine like terms. Although this is just an x, we can think about it as 1x. So you're like, okay, if we have our team again, how many are on the x team? We have 4 on the x team, so 4x. And we combine like terms equals 4. And then we divide both sides by 4 to get x by itself, right? It's the opposite of multiplying by 4. So now here we have 1 equals x. And if we were to plug that in for x here and plug it in for x here, we will see that we will get 3. Over here we have our distributive property, so we'll definitely go over this one. Our distributive property, all we're doing is taking what's on the outside, that whole negative 1, not just the 1, but the whole negative 1, multiplying it by negative 5, and multiplying it by positive 2. So negative 1 times negative 5 will give us 5. Negative 1 times positive 2 will give us negative 2. So 1 plus negative 2x equals 15. All right. Now I'm going to subtract my 5 here, subtract my 5. So now I have 2x, negative 2x, excuse me, equals 10. So I need to divide not just by 2, but the whole thing we see here, negative 2. And then I have x equals negative 5. All right, x equals negative 5. I like to rewrite it so the negative sign is really out there. And if you were to plug that in, then you would get 15. All right. Moving on to 16, I understand that an equation can have a solution, no solution, or all solutions. So June solved her equation and got 4 equals 4. What is her solution? What does that mean? Okay, now imagine that before she solved her equation, it was like x plus 4 equals x plus 4. And let's say we wanted to subtract x from both sides. Like, I'll give you an example in a bit, but here we'd have these x's cancel out, these x's cancel out, so we'd have 4 equals 4. All right? And so what that means is if we were to take any value and put it in for x, so x equals 6, x equals 10, x equals 11, whatever we want to choose for x, and if we put that in for our initial value, let's say we had 6 plus 4 equals 6 plus 4, or we did 10 plus 4 equals 10 plus 4. It doesn't matter what we put in for our x, whether it's 6 or 10, 6 plus 4 is always going to be equal to 6 plus 4, and 10 plus 4 is always going to be equal to 10 plus 4. And so when we see our solution like we see here, it means that we can put anything in for x, anything. And so when we go through our options of no solution or all solutions, it's going to be all solutions. You can put anything in for x, and the equation will still make sense. It'll be true. All right, so now we're looking at B. Pat solved a different equation and got 6 equals x. So let's go ahead and put our x's back into it. X plus 6 equals x plus 8. Well, here it doesn't matter what we put in for x. There's no way that we could get our equation to equal the other side. Meaning if I put in 12 for x here and 12 for x here, 12 plus 6 is going to give me 18, and 12 plus 8 is going to give me 20. And we know that that is not true. And so in this case, we do not have any solution. All right, so we go to no solution, final answer, and move on to 17. Now, just a reminder, please show all of your work just like I'm doing now. Very, very crucial. Otherwise, I cannot give you credit on your test. I can solve simple problems by using an equation and solving it. How can you represent the description below with an expression? Julian is 3 inches taller, or 3 inches less, that's big, than twice Marine's height. All right, so I'm going to use a J for Julian and an M for Marine. And here we're doing whatever twice Marine's height is, so 2 times Marine's height, 2M. Minus 3, right, because 2 inches or 3 inches less than equals what Julian's height is. So does that make sense? We start with twice Marine's height, subtract 3 from it, and that's going to give us Julian's height. Now it says, now if Marine is 32 inches tall, how tall is Julian? So now all we're going to do is take 32 and plug it in for M, because that is Marine's height. So we're going to do 2 multiplied. Actually, I'm going to do this in a different color so you really see the relationship here. We're going to do 2 multiplied by 32, Marine's height, minus 3 equals Julian's height. All right, so it's the same equation as above, except all we did is plug in 32 for M, Marine's height. So now as we solve here, we're going to do 2 times 32, which is 64, minus 3 equals J. 64 minus 3 gives us 61. 61 equals J's height, Julian's height. So how tall is Julian? 61 inches tall. Yes, that is my final answer. And why? I would just say I showed it with my work. So like why? I showed it with my work below. All right, you don't have to go into major detail. I can evaluate expressions using the order of operations. All right, so let's think about what our order of operations are. We have P, E, M, D, A, S. That is PEMDAS. And one thing I want to stress is that it doesn't matter the order for parentheses or exponents, right? It's just simply parentheses, then exponents. But the order from left to right in which multiplication or division comes, that's going to be which one you do first. Same with adding or subtracting, whichever one comes first, left to right. So we start with parentheses. All right, that's things that look like this. So here I see in parentheses 2 plus 3, and that's about it. The other parentheses are just telling me multiplication. So let's go ahead and simplify, and we'll do that down here where it says show your steps. So I'm going to rewrite it so I have room. All right, take your time to do this. Not only will you end up with the right answer, but it also shows me you understand what's going on in the order of operations. So parentheses. It's the first thing I'm doing. So I'm going to rewrite my equation the exact same way. Yes, I know some of you are rolling your eyes at me right now, but you're going to write it the exact same way. Except now instead of 2 plus 3, we have 5 plus 2 times 5. All right, so we just did parentheses. And now we're doing exponents. Ooh, luckily, we do not have any exponents, right? We don't see any like squares up above or like to the third power. So we can go ahead and cross that one off. Now we're looking at multiplication or division, and I'll go ahead and highlight this in red. So whichever one comes first from left to right. Ooh, we don't even see any division. How about it? So we're going to rewrite the problem exactly how we see it, except we're going to solve these multiplication terms. All right, we'll talk about terms in just a moment. So we have 2 plus 3 times 3 is going to give me 9, plus 5 times 5 is going to give me 25, plus 2 times 5 is going to give me 10. And so now we can move on to adding or subtracting. We don't see any subtraction, so we don't have to worry about it. 2 plus 9 gives me 11. 25 plus 10 is going to give me 35. 11 plus 35 is 46. So if we were to show all of our steps and simplify, this is what our final answer would be. 46. So that's the same thing as this expression, except it's in simplest form. Now, how many terms are in the expression? Now here, let's say I was stumped. I could Google what terms are. I could look in my math book, but I don't want to waste your time. So terms, that's going to be all of the parts of the expression. And so basically anything that you have to do multiplication to simplify. So like 2 times 5, I need to get that to 10, or like 5 and then distribute it to 2 plus 3 to get that to 25, right? Then that's when it's in our simplest form in single constant terms. But whenever it's separated by like a plus sign, then you're going to expect a new term. So here we have 1, 2, 3, 4 terms. I'm going to highlight them in blue. I apologize if my explanation wasn't the best. Sounded better in my head, but basically it's all the different parts that make up the expression. So 4 terms. Evaluate each of the following expressions, and this is the last one, so you guys can give yourself a round of applause and eat some nachos. Explain how each of the following expressions can be simplified. So let's go ahead. Evaluating, that just means simplify, solve it. So remember PEMDAS, order of operations. Start with parentheses. No parentheses here in the first problem, so we can simply move on to the next part. No exponents. So now we move on to multiplication or division. Here we see multiplication. I can go ahead and put parentheses around it if I wanted to. So I do 6 plus 40, because that's 5 times 8. That's going to give me 46. Boom. I will leave this one for you guys, and then we'll do E together. So here we have parentheses right here, 4 plus 7. That is going to be 11. So I'm going to rewrite everything exactly how I see it above, but do my parentheses. And then I need to do exponents, but there are no exponents. Then I'm looking at multiplication. I do see multiplication right here, right? So let's see, 3 plus 22. And then I can do my adding or subtract. In this case, it's just adding. So that's going to be 25. All right, hopefully this makes sense. Hopefully this helps. Please remember to show all of your work. All right, if you don't show your work, we cannot give you credit. Just a quick reminder for these problems here, I always like to write an X along with my final solution. So like 6 equals 8, I would just put X plus 6 equals X plus 8. And does that equal each other? No, it does not. So there'd be no solution. Otherwise, it's all solutions if they are equivalent, if it's a true statement. All right, please let me or your other teacher know if you have any questions here. Otherwise, this is all good to go. All right, thank you very much. Have a good day.